Good morning, guys. Welcome back. Today, inshallah, we're gonna pass and we're gonna start in a new section, section two of chapter five. So we're gonna start in chapter five. We're starting by section two. Section one will not be explained, or section one actually will be included in our material. So, like this, we already started by chapter three. We finished section two and three, then chapter four, section three, and now chapter five, section two. So let's start here, guys. Okay, so in the beginning, we need to know what we're going to learn in this section. So our sections talk about the electron configuration and the periodic table. So we already studied the electron configuration and how we could distribute electron in the sub-energy level around the atom or around the nucleus of the atom. So today we're going to apply this electron configuration and the periodic table, or we're going to find the relation between this electron configuration and the periodic table. So by the end of this lesson, we should be able to explain the relation between the electron sublevels and the length of each period of the periodic table. Locate and name the four blocks of the periodic table, explain the reason of these names, and finally here we're gonna find to discuss the relation between group configurations and the group numbers. Finally, describe the locations in the periodic table and the general properties of alkali metals like alkaline earth metals, the halogens, and noble gas different or the major groups in the periodic table. So let's start and okay, find what we do. So periods, unplug the periodic table. So of course, as a table, so we know like any table, it's made of columns and rows. Okay, so the columns in the periodic table are called groups, while the rows are called periods. So the word periods here, it means the horizontal rows, okay, of the table, while the groups mean the vertical columns. So here we find that we're gonna find that elements already arranged in groups. Okay, these groups, or what's special about this group, that the elements which are in the same group, they have similar chemical properties, or they share similar chemical properties. So we find, for example, the entire group are metals, the entire group they are tiny, the entire group they are somehow easily react with gases or some. So whatever the chemical properties of each group differ, of course, depending on the elements which are found in this group. So that's mean, let's look here, guys, to the periodic table, okay, or just like look, take a look here. So that's our periodic table. So we could easily find it's made of groups. This vertical columns, we call them groups. So we have group 1A to A and so on like this, or all these are groups. So if we count the number of groups, we're gonna find the R18 column representing a 18 group, okay. And also they are made of horizontal rows. These rows are called periods, and we find the number of periods are 7 periods. So elements which are found in the same group, they share the same chemical properties. So we're gonna find all these elements, okay, beryllium, magnesium, calcium, okay, strontium, and blah 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 like this. All these they are having, or they have the same chemical properties. Also the same here, fluorine, chlorine, bromine, iodine, and so on. All these they have the same chemical properties. So elements which are located in the same group, they have or they share similar chemical properties. So that means we could predict, if we just know the properties of one of these elements, we could predict the properties of the following elements, okay. So like this, that's a group. About the periods, here we have 7 periods, okay. So this number 7 is not new number, okay. Somehow we are gonna find this number is usual for our in our ears. So the number 7 actually, as we studied before, it represents the number of the main or the principal energy levels. So it means each period represent the energy level. So here that's mean number 1 that represents the energy level 1, or K L M N O P Q. Okay, so here they are the main or the principal energy levels, which we know them. So each period represents an energy level. If we keep looking at the periodic table, we're gonna find not all periods they have the same length. That means the first period only just have 2 elements, hydrogen and helium, while the second period it has 8 elements, lithium, beryllium, okay, and so on till we reach neon, okay. The third one it has about 8 also, okay. Then the fourth one we have 18 and so on like this, okay. So why we have this different number of elements, right? Not all the periods they have the same. That means it's not a uniform table. This table actually is not uniform. Some rows are longer than the others, okay. And as we hear, there is something I want to refer to you. Look at this part, guys. Here actually we're gonna find that if we maximize this, we're gonna find perium is 56, while here we have this hafnium, okay, is 72. So that means we have some elements in the middle that's here. So actually these two these two rows, they supposed to be located here, okay? But to avoid that the periodic table be too wide, we just remove them and make them as two separated lines beneath the table. So here we're gonna find that the periodic table elements are already arranged in ascending order regarding to the periodic to the atomic number. So these two suppose, which means actually here this row will have more elements than the row before it. So whatever we need to know here, or what we need to find out, that each row has different number of elements. That's based on what? That's based, as we said, each row represent a energy level, and we know that not all energy levels they have the same number of sub energy levels. Some energy levels just contain sub energy level S, like the first one. Second one has S and P, third one SP and D. So like this, as regarding to Aufbau law, which we studied in the electron configuration, we start to fill the lower energy sub energy level, then we pass to the higher. It means, okay, that's here also the periodic table. Each row represent the number of elements, or carry a certain number of elements that is represented by the amount of electron that could be filled in the sub energy levels in this main energy level. Okay, so to clarify the idea to you, back to me here guys to watch this. Okay, just guys, sorry. So here we see that elements are also organized horizontally in rows or periods, okay? And the length of each period, that means the number of elements which found in this period, determined by the number of electrons that can be occupying the sub-levels being filled in that period. So that means the first period or the first row, it just have the sub-energy level S. So that means it just will be filled by 2 electrons. So it's supposed to have 2 elements only. So hydrogen and helium, as we saw in the periodic table. The second one, it has S and P, so it's supposed to be filled by 8 electrons, 2 in S and 6 in P. So suppose that we have 6 elements. So also that's which we observe. So let's apply this in the periodic table together, guys. Here, the first one just have 2 elements because it just sub energy level S, while here S and B, so we have 2 electron in S and 6 in B. Then in the third energy level, we have 2 in S and 6 in B. And before we fill the 3D, we know that it's better to fill for S. So that's why the D level of the third period doesn't appear before of the third sub energy level doesn't appear before the fourth period, because already we know that it's better to fill 4S before we start to fill 3D, because 4S is considered to be lower in energy than the 3D. So here are these elements, okay, or this element, the extra one that is not found in this, represent the D sub energy level, which is already the 3D, which belongs to this period. But as we know that the 4S is lower energy, so they start to appear in the fourth period instead of the third period, and keep so on, okay, to the others, okay. And here, of course, we're gonna find the have extra element that's supposed to be added here, which represent the sub energy F. So F actually is not appearing in this one, okay, or it's supposed to, we start to have F from that fourth energy level, but as we know, it's better to fill the 5 S before we pass to the F. So here like this, we find the F level start to appear from the 6th and 7th period, okay. So here, that's the idea that each period, okay, represent energy level, and of course this energy level is divided into sub-energy levels. So the number of elements in each period based on the number of electrons that could be completely, or that could complete fill the sub-energy levels in the main energy level. So here, back to our point, guys. We find the periodic table is divided into 4 blocks, as we can, or 4 main parts: S, B, D, and F. So this word represent the sub-energy levels, and we call them in this name, okay, that determine the electron sub-energy level that it's being filled in the block. That means here, but if we back again to the periodic table to see this, okay. Here, as we could easily recognize that the energy, or we could recognize that the periodic table is divided into 4 parts, okay, or simply divided into 4 parts, as we can see. What are these 4 parts? The first one here, okay, then the second one here, okay, and the one in the middle, and the fourth one, which is down here. So that's actually called the S block, that is the B block, and that is the D block, and finally here we'll find that F block. So what it represents, the sub energy levels, which mean each block represent the energy level that's completely filled. So whatever the elements which found here in this part, so they, or the outermost energy level, they're gonna be the S, or that's the higher energy level that's gonna be occupied, while here we're gonna find they filled the sub energy level D, while here we filled just B. So S, it means that we filled S, okay, B, that's filled B, D, and F like that, okay. So that's mean here the elements which found in this block already, okay, they could occupy the sub energy level D, while these elements of course no D, and this elements no D. Here just we contain S, here P and F like this. So like this, guys, each block represents the sub energy level that could be filled by electrons. So here it means that actually the periodic table somehow reflect the idea of configuration, or the idea of distribution of electrons within the sub energy levels. So here, back to our point. So here do we find that's our periodic table. So we find the first, we're gonna start talk about each group of the periodic table. We're gonna just talk about group by group, or the major groups of the periodic table. So we start by group number 1 of the periodic table, which is known as alkali metal. So the first group in the periodic table, we call them the alkali metal, the first one over, okay, that's which was started by hydrogen. So actually if we talk about this, we're gonna find lithium, sodium, potassium, rubidium, cesium, and francium. They are the elements. So where is hydrogen? Actually hydrogen doesn't belong to this group as a properties, but it just located here because its atomic number is 1. So although it's have just 1 electron or 1, okay, proton, so it's supposed to be located in this, but actually it doesn't share the same. So it's a kind of a special case, or that's come. Also helium is another special case in the periodic table, because we know helium is 2, so supposed to be added in group 2, but because its chemical properties doesn't share with that, so we've located with the noble gases, because its outer energy level is completely filled, so it will not share in chemical reactions and so on. So we put it in the last group, the noble gases, because it shares the same properties with this group. So in this case here, we have 2 special cases. So let's refer to them in the periodic table to make it clear for you. Here, actually, guys, we find the hydrogen. That's why it's colored in green, while the entire group is colored in red. So here we find that hydrogen actually is different than others. So hydrogen, it's location, or it's located in the first group, but actually its properties is completely different than the rest elements of these. So we don't consider them as one of the elements of alkali metals, okay? And also here, helium is another special case, because helium is 2, so supposed to be located here, but actually we don't locate it here. We just separate it in this part, okay? Why? Because its chemical properties, okay, is exactly the same like the chemical properties of the other elements in this group, butane, or the noble gases. So helium, neon, argon, krypton, xenon, and radon, they all of them, they share that they are very, very stable. Their outer energy level is completely filled, so they don't share in chemical reaction. So it's better to put helium in this, because it represents chemical properties rather than putting in its original position. So helium and hydrogen both are special cases. They are located in positions which actually is not matched, whatever, whether the chemical properties, or even they are put in place, or even helium is put in a place which you match with its chemical properties, but it's not the original position of the periodic table. So let's talk about the first group, which is alkali metals. So from its name, metals, okay, so why we call them, or what is most important properties of metal? So of course, you know a lot of properties about metals. You can explain to me, okay, or you could figure out. So if we ask here about what's the main characteristics, or what the properties of metals, so you could figure things that you can say. The physical properties, that most metals, they are somehow solid, yes, okay. So we find that most metals, they are shiny, or they have a kind of luster, okay, yes, they could reflect light. And we could find also that metals are good conductors of electricity, good conductors of heat. All these are physical properties about metals, we know them. So here, these are the predicted characteristics of the of metals, or the alkali metals. So we talk about all what we said about it is the physical properties, okay, but now we need to postulate some chemical properties. What are new properties, or add something new, or about these properties? So here we find that in their pure state, okay, all alkali metals have a silvery appearance, okay, and they are soft enough to cut with a knife. So that means they are solid, but still soft to be easily cut with a knife, okay. So no one think they are gases or they are liquids. No, they still solid, but easily to be cut, okay. And here also we find the elements also. So before we pass to alkaline earth metal, alkali metals also we call them alkali metals because usually they always try to dissolve in water and they release hydroxide ions, or they could easily replace water, hydrogen of water, and that's why they create a kind of hydroxides bases, okay. That means once they react, so here just to show it to you, we said that for example once they easily here, just a minute. For example, if we get one of these, like for example Na, that is the sodium, one of the alkali metals that react with water. So water actually we know is made of H and OH. So because they are two reactive elements, so they easily could replace the hydrogen. So finally we are gonna find it's NaOH plus H2 is going to be released out as hydrogen gas. So NaOH, that's sodium hydroxide with a base, okay, alkali. So that's why we call them alkali metals, because simply they could replace the hydrogen of water and produce hydroxides, and that's why we call them alkali metals. Actually, all alkali metals, they are most reactive elements in the periodic table. They are too reactive, or the most reactive metals. Okay, they simply, or in nature, it's hard to find them as a pure metals or the pure elements. Always they are combined with other substances, and in lab, to keep them or to save them, we must put them under kerosene or under oil. That's to prevent them to react with the oxygen of the atmosphere. So here it presents how much they are reactive, or how they could easily react. We find that all alkali metals, they already occupy S slot, okay, and actually group one. So we are gonna find that all of them, they have electron configuration that end by S sub energy, and they just contain one electron in this sub energy level. So during chemical reaction, they easily lose this electron and turn to be a positive ion, okay, or positive one ion. So for example, let's take an example to clarify the idea. Sodium Na11. So once make a kind of electron configuration. So we have 1s2, okay, 2s2, then 2b6, and then 3s1. Okay, so we're gonna find that in by one electron in sudden. So during chemical reaction, it's easy to lose this electron, and in this case, sodium will turn to be a positive ion. Positive just carry one positive charge by one positive because it just lost one electron only. So here we find all the alkali metal have these properties, or they are sharing these chemical properties. So we find that the highly reactive metals, they could react easily with water replacing its hydrogen, and in this case they would provide hydroxide. That's why we call them alkali, or that's why we call them basics, or form some base substances. And they easily lose the electron oil of the outermost energy level, and in this case also they are gonna find. Also we find that these alkali metals, they highly reactive, they could easily react with halogens, the elements which are found in group 7a, or the group or in the 17 column of so group number 17 in the periodic table. Okay, so for example, we find that sodium is easily react with chlorine, okay, to form sodium chloride. Chlorine, one of the halogens, okay. Also they could react with fluorine, bromine, whatever, okay, any element that found in the group number 17 in the periodic table. So all these are properties about the alkali metals, okay. Then we pass to the second column, which is elements of group 2 of the periodic table, which is known as alkaline earth metal, okay. So here, that's another word. So they somehow look like the first group. They are alkaline, alkali, metals. So the new word, which is earth. Okay, so what the difference, or why the reason of this naming? Okay, because actually they are the most abundant elements, or the most abundant metals in the earth crust. So that's why we call them alkaline earth metals. So because they already found a lot in the earth crust. So they include beryllium, magnesium, calcium, strontium, barium, and radium. Okay, they are different elements which found in the same group. They share also the chemical properties like the first the elements in the group 1A or the first group, but with a little differences. So what are these differences? Let's see together, guys, here. So here we said that they are less reactive than alkali metals, okay, but are still too reactive to be found in the nature in the pure form. What does it mean? Actually, they share the same properties like alkali metals. That means they are metals, good conductors of electricity, good conductors of heat, okay. Also, they are shiny, they are solid, okay. Somehow they are soft enough to be cut also. But actually, the difference here back to the reactivity. What mean by back to the reactivity? Actually, we find that the reactivity of second group is less than, which means the alkali metal is more reactive than alkaline earth metal. But it means that it's not reactive. No, it's still too reactive compared to the other elements or to the other metals in the periodic table. So why actually they are not, or why they don't have this reactivity like the first one? Okay, so we're gonna find, or we are gonna that these elements are found in group 2 of block S, which means that, okay, they're already at the outermost energy level S will go, or sub energy level will be S, but it will be filled by 2 electrons, okay, while here it's S but filled by 1 electron. So of course it's easier to lose 1 electron than losing 2, which means that the elements of group 1 is easier to ionize or easier to turn to ion and react rather than elements of group 2, because elements in group 2 they supposed to lose 2 electron instead of 1. So that's why they are less reactive but still reactive metal, and also they could combine or they perform the same or work in the same manner or the same behavior once they react with other chemical substances. That means they could react with water, placing its hydrogen and forming hydroxides, which are bases or alkalines. So that's why we call them alkaline metals. And also they could react easily with the halogens or group 17 of the periodic table. So actually they share the same chemical properties and somehow the same physical properties also, but the difference that alkaline earth metal is less reactive than the alkali metals. That's also why we can't find them, okay, pure in nature, because they still or they still reactive. That means they already are found in the nature combined with other elements, okay, forming compounds. So here we're gonna find hydrogen here. As we said, the hydrogen, suppose that has an electron configuration of 1s1, but despite the ns, okay, configuration, it does not share the same properties of the element. That means regarding to its electron configuration, supposed to be located at the first element of group 1, but actually doesn't have this elements, the same properties. Hydrogen actually is a gas. It's a unique element, has different properties. So why here we said that? We said that it's gas, so of course it's not metal, it is not shiny, it is not, so it doesn't share the properties of group 1. It has its own properties, okay, so it's actually a gas, although it just have 1 electron in the outermost energy level. So here, which make it special case, but we just located in this position regarding to its electron configuration, okay. So here we find, for example, group 2, the helium, suppose that it has that's mean 1s2, okay, so supposed to be located in the second group, but we just put it in group 18 because it have the same chemical properties like the other noble gases, okay. So here these are 2 special cases, as we said before, okay. That's why their position is not matched to their electron configuration, or their position is not matched to the chemical properties of the group which they are located in, okay. So here, like this guy, that represent the idea, as what we said it in the first part, on the first slide, that each period represented by the number of elements that could be filled with. So we find that period number and number of elements in the period and the sub energy level. That, so period 1 we have 2 electrons, so that means we have 2 elements, because just here sub energy level S only that gets filled by 2, and second period 8, and third one 8 also here, and the fourth is 18. So here we just added the 3D. That's why we find here, that's why it's longer, 10 more elements in the fourth period than the third period, because the 3D start to appear in the fourth period, because we know that spur 2 fill 4 is before 3D, and so on in the other periods. So here, let's find, that's one of the most important thing here. let's find how we could or locate an element, okay, to find its block and the periodic table, okay, so and its period. So how could we know this? So he asking you, for example, without looking at the periodic table, identify the group, period, and the block, which the element that has, okay, the electron configuration, and he already give you the electron configuration, okay. So 6s2 is located. So how could we know? So simply the answer is given here, okay? So to know or how to answer, we should recall something, okay, or to remember something. We said that each period represents a main energy level, okay? And of course, and we said that the periodic table is divided into 4 major parts, which represent the 4 sub-energy levels. So here by looking to this, okay, we could find 6 that represent, or this number 6, what does it refer to? It refers to the number of energy levels. So that the 6 energy level, which refer to the number of periods. So we could find that it's period 6. And here S means in which block is it? It's in block S. So here we're gonna find it's block S. And then in which group we could find, or he asking, can we find? Yes, the group is represented by the number of electrons that's filled. So we have 2 electrons, so it will be in group 2. So like this, we said that in period 6, okay, period 6, block S and group 2. So let's find if the answer is true here, guys. So here, then, the asking, so back to this point, sorry, let's look at the periodic table. So we said that here group S, so that's our element, okay, because that's xenon, okay, and they're referring to xenon. He said that in the 6th level has 2 electrons, so that the first electron, then the second, so that's our element, okay, which is the barium. So it's found in period 6, block S and group 2. So back to the point. Okay, here he asks you, without looking at the periodic table, write the electron configuration for group 1 element in the 3rd period, and this element likely to be more reactive or less reactive than the element described in A. So here, that's a very, very important question, okay? He comparing to these two guys. So he asked that this one in group 1, so that means the outer energy level will fill by 1 electron, okay? And as it group 1, so of course in block S. So like this, we are gonna answer it in this way. Let's translate the given, or just to find what are given in this one here. He asked you, he said this one, let's see it together here, guys. He said without looking to the electron configuration, without looking to the periodic table, write the electron configuration for group 1. So group 1, what I could figure that the outermost energy level will just fill by 1 electron. And here, as it group 1, it means in block S. So we have S1. It must end by S1. Okay. And he said in 3rd period. So that means it's supposed to be 3S1. So I could predict whatever. So before 3S, suppose we have 2B6, 2S2, and 1S2. So the total would be 11. Okay. So I don't know what he said. Okay, don't look at the periodic table. So it's not our problem. Okay. Actually, it's sodium. Okay. But he asked not to look. Okay, so it's not our problem to know what the name of the element. So he asked you, what do you predict? Is this element going to be reactive or less reactive than the element described in A? So here, this is supposed to be reactive or less reactive than, well, actually, as we know, okay, or as regarding to what we know, that elements in group 1A is more reactive, or in group 1 is more reactive than element in group 2. So as we located this one in group 2, and that's in group 1, so suppose this one is more reactive than the other one, okay, or the element, or in problem A. So here, like this, how we could answer, how we could figure that electron configuration, or the periodic table actually reflect the electron configuration, or the electron configuration help to locate element in the periodic table. Or so here, like this, we find, so here that the answer the same, we said that. So we said the element in group 2, and because, and here it's or the sub-energy level S is 2, and here in the 6th period, because already in 6S, and here we find that in the S block, and then we find in the 3rd period element, so the highest occupied energy level will be 3, which means okay, and that's of course in the S level. So we're gonna find the electron configuration will be as we did. Okay, so that is the sodium. So we find because in group 1 this element is likely to be more reactive than 2, so that's our exactly as we answered, guys. So that will be in the end of our lesson. Okay, we are gonna stop at this point, and next time inshallah we're gonna continue this section. If you have any question, okay, you can contact me. Thank you and goodbye.